This is a C-5 Galaxy. This is a C-17 Globemaster. And this is a C-130 Hercules. These three transport aircraft shoulder over 95% of the U.S. Air Force's transport missions, forming a comprehensive airlift system. In terms of size, the C-5 is the largest, 75 meters long, 20 meters tall, with a wingspan of 68 meters and a maximum payload of approximately 130 tons. The C-5 is a strategic transport aircraft, primarily tasked with moving cargo between U.S. bases and military installations worldwide. Due to its heavy payload and long-range capabilities, it demands high-standard airfields and can only land on paved runways, typically handling rear-area logistics far from the front lines. Currently, 52 C-5s are in active service, making it the flagship of the USAF's transport fleet. Next in line is the C-17. The C-17 measures 53 meters in length, 16.8 meters in height, and 51.8 meters in wingspan, with a maximum payload capacity of approximately 77 tons. As a strategic tactical transport aircraft, it can execute long-range strategic missions to rapidly deploy troops from domestic bases to rear military installations, fulfilling strategic deployment needs. Simultaneously, its superior design and short takeoff landing capabilities enable the C-17 can land on unprepared surfaces, requiring a minimum runway length of just 900 meters. This enables tactical transport missions from rear bases to the front lines. Currently, the C-17 fleet comprises 222 active aircraft, forming the backbone of the U.S. Air Force's transport fleet. Finally, the C-130. The C-130 measures 30 meters in length, 12 meters in height, with a wingspan of 40 meters and a maximum payload of approximately 19 tons. As a tactical transport aircraft, the C-130 primarily handles short-range transport missions on the front lines. It has minimal runway requirements. As long as the surface isn't excessively pitted or uneven, the C-130 can operate. Equipped with rocket boosters, the C-130's minimum takeoff distance can even reach 230 meters. This capability proves invaluable in harsh frontline environments. With 277 active-duty aircraft, the C-130 fleet represents the most versatile transport force in the U.S. Air Force. How did U.S. military airlift operations, exemplified by these three transport aircraft, evolve step by step? And how did these three aircraft undergo rigorous selection to become the backbone of today's fleet? Welcome to Chris's Military Base, where we spotlight military equipment from around the world. Today we examine U.S. airlift operations. In 1948, the U.S., Britain, and France initiated currency reforms in West Berlin to stabilize Germany's chaotic economy and counter Soviet influence. This rapidly deteriorated relations between the Soviet Union and Western powers. By June, Soviet forces had blockaded all ground and water routes to the Allied-controlled sector of West Berlin, igniting the first major international crisis of the Cold War era. As time passed, conditions for West Berliners deteriorated rapidly. The city's food and coal supplies were cut off, with daily requirements reaching 35,000 tons of essentials like food, milk, coal, and gasoline. With seemingly no viable means to deliver supplies to the residents, on June 29, 1948, the Allies unveiled a new strategy, launching an unprecedented airlift operation to supply essential goods to West Berlin. The Soviets argued that airlifting alone could not sustain a city of 2.5 million people, insisting that such massive logistics required rail and road access. Consequently, the three air corridors to West Berlin remained open, presenting an opportunity for the Allies. However, the operation proved far more complex than anticipated, demanding a vast fleet of transport aircraft. The U.S. military deployed a fleet of 225 C-54 aircraft, joining other Allied nations to airlift supplies. Over the course of a year, they conducted 278,228 flights, delivering 2,326,406 tons of goods to Berlin, including fuel and food. The original plan called for daily deliveries of 3,475 tons of supplies, but by the spring of 1949, the actual daily transport volume often doubled, with a peak of 12,941 tons in a single day. As time passed, the airlift's impact became evident. By April 1949, airlifted supplies even surpassed the volume previously delivered by rail to the city. The success of the Berlin airlift rendered the Soviet blockade meaningless, prompting the Soviets to lift their blockade of West Berlin in May 1949. This monumental airlift triumph profoundly demonstrated to the U.S. military the critical importance of transport aircraft. As the saying goes, before the troops move, the supplies must precede them. On the battlefield, logistical support is paramount. For the U.S. military to establish a global combat system and expand military deployments worldwide, possessing a vast transport fleet was essential. At that time, most active-duty U.S. military transport aircraft were outdated. World War II-era piston engine models, with their range, speed, and cargo capacity becoming increasingly inadequate. Consequently, they urgently needed a new aircraft to shoulder this critical responsibility. On February 2, 1951, the U.S. Air Force issued the General Utility Requirements (GUR) for a new transport aircraft. Simply put, the proposal called for a multi-purpose transport capable of withstanding the harsh conditions of the front lines, while offering sufficient cargo capacity to allow vehicles to be driven directly onto the aircraft. 5 aviation giants participated in the bidding, with Lockheed's proposal leading the pack. Initially, Lockheed's renowned engineer, Kelly Johnson, was skeptical about the project. He believed that if Lockheed took on this contract, it could potentially ruin the company. He had no interest in such a slow, unarmed aircraft, and bluntly called it the ugliest aircraft he had ever seen. If you don't know who Kelly Johnson is, just understand that iconic aircraft like the P-38, U-2, SR-71, all iconic aircraft of the highest caliber. His words carried significant weight within the industry. However, Lockheed President Robert Gross did not heed his advice. On the contrary, he believed this aircraft would not only meet current needs, but also shine brilliantly in the future. Looking back today, the C-130 has undoubtedly achieved this. The first C-130 made its maiden flight on April 7, 1955, and has dominated production lines ever since. Even today, the C-130J remains in active production, making it the longest produced military aircraft in history. Spanning over 70 years, the C-130 has evolved into dozens of variants, tackling missions ranging from transport and electronic reconnaissance to long-range search and rescue, armed strikes, firefighting, and aerial refueling. It can handle virtually any task you can imagine, though its primary roles remain frontline transport and armed combat. We previously covered the armed strike version, the AC-130, in a dedicated video. Interested viewers can check it out. As for frontline transport, it's arguably the C-130's specialty. Speaking of which, we must mention its various impressive feats. Landing on unprepared surfaces is just basic operation. Beach landings, grass field landings are nothing special. With skids installed, it can even land on ice. But the most remarkable feat was its aircraft carrier landing. In November 1963, the C-130 achieved 29 touch-and-go landings, 20 arrested landings, and 20 unassisted takeoffs on the USS Forrestal aircraft carrier. They tested carrier operations under various payloads, with aircraft weights ranging from 38 to 55 tons. These remarkable feats set numerous records. To this day, the C-130 remains the largest and heaviest aircraft ever to land on an aircraft carrier. Through extensive testing of this experimental data, the U.S. Navy concluded that the C-130 could transport 11.3 tons of cargo over 2,172 nautical miles and successfully land on an aircraft carrier. Its outstanding performance thoroughly impressed the Navy. However, the U.S. Navy ultimately deemed such transport missions too risky, opting instead for the smaller C-2 Greyhound. This decision alone underscores the C-130's unparalleled takeoff and landing capabilities. Had rocket boosters been added to this foundation, the C-130 could have truly become an interstellar spacecraft, capable of achieving what no other transport aircraft could: vertical takeoff and landing, and perform ultra-short landings, feats beyond the reach of other transport aircraft. Thanks to the C-130's exceptional adaptability during the Vietnam War, the U.S. military developed a specialized airdrop solution for rapid supply delivery to target zones. Known as LAPS, Low Altitude Parachute Extraction System, it addressed the challenges of complex terrain that often prohibited large aircraft landings. Traditional airdrops couldn't ensure precise delivery to target zones. Thus, the U.S. military developed an ultra-low altitude delivery method. The aircraft would open its cargo door while flying just above the ground to release supplies. Subsequently, deceleration parachutes deployed within the cargo would stabilize the descent. The challenge lay in delivering heavy payloads at such low altitudes, which drastically shifted the aircraft's center of gravity, making control difficult. There was also a high probability of the landing gear touching the ground. If the aircraft was too delicate or difficult to handle, such missions would be virtually impossible. Only a rugged aircraft like the C-130 could handle this task. Overall, from the perspective of tactical transport aircraft, the C-130 is exceptionally capable. No matter how harsh the frontline conditions, it delivers supplies rapidly, reliably, and efficiently, a key factor in its enduring relevance despite evolving challenges. With such a perfect tactical transport in place, attention naturally shifts to strategic transport. By 1960, at the height of the US-Soviet rivalry, tensions between the two blocs were escalating. War could erupt anywhere on the planet. At that time, the US military operated a vast fleet responsible for combat logistics across its bases. The largest transport aircraft then was the McDonnell Douglas C-133, a turboprop capable of carrying over 50 tons of cargo, a formidable aircraft indeed. Yet, for intercontinental transport, it still fell short. They needed a truly massive aircraft, large enough to carry virtually any cargo, weaponry, or equipment and rapidly deploy them anywhere in the world. Simultaneously, the emergence of the N-22, which became the largest propeller-driven aircraft, greatly stimulated the Pentagon. In 1964, the Heavy Logistics Transport System CX program was officially launched. 5 companies, Boeing, McDonnell Douglas, Lockheed, General Dynamics, and Martin, joined the bidding process. Pratt & Whitney and General Electric engaged in fierce competition for the engine contract. After a year of intense rivalry, in 1965, the Pentagon announced the winning bidders. Lockheed would manufacture the future heavy transport aircraft, with General Electric responsible for the engines. Both companies immediately plunged into aircraft production, beginning construction of what would become the largest aircraft in U.S. military history. In March 1968, after 2.5 years of effort, the C-5 Galaxy officially debuted. This colossal aircraft, measuring 75 meters long, 20 meters tall, and with a wingspan of 68 meters, astonished the world. It instantly became the largest aircraft in existence at the time. The C-5 was equipped with highly advanced flight instruments, autopilot and navigation systems, and an internal fault detection system comprising 600 sensors. All critical systems featured redundant designs, including 4 parallel hydraulic systems. To lift this behemoth, General Electric deployed its full expertise, incorporating cutting-edge technologies and materials to develop the revolutionary TF-39 high-bypass turbofan engine, significantly boosting air intake, fuel efficiency, and thrust. Each engine delivers 20 tons of thrust. During testing, a B-52 bomber served as the flight platform. Just 2 C-5 engines provided more thrust than the B-52's 8 engines combined. 4 engines enable the C-5 to soar through the skies. Only this abundant power allows the colossal C-5 to unleash its formidable capabilities. Returning to the C-5's core feature, its cargo hold, it measures 5.8 meters wide, 4.1 meters high, and 37 meters long. The Wright brothers could even complete their first flight within the C-5's cargo hold. The cargo hold floor is specially reinforced to carry heavy loads and can quickly pivot to a side equipped with pulleys for easy loading and unloading. During loading, the aircraft's main landing gear lowers, while the nose gear retracts backward, lowering the plane into a kneeling position close to the ground. Hydraulic actuators would then raise the nose upward. The twin rear doors would open, deploying ramps that transform the C-5's cargo hold into a massive two-way hangar. Crews could load and unload cargo simultaneously from both ends of the aircraft. With a maximum payload capacity of 130 tons and a maximum takeoff weight of 418 tons, the C-5 could easily transport most U.S. military equipment like Chinooks, Apaches, Blackhawks, Super Stallions, M1 tanks, M2 infantry fighting vehicles, Humvees, M109 howitzers, and howitzers can be loaded. It can carry up to 36 pallets, 4 times more than the C-130. During the Fourth Middle East War, to support Israel, the C-5 fleet conducted 145 sorties over 32 days, delivering 10,800 metric tons of supplies to Israel. Each flight averaged 74 tons of cargo, continuously supplying Israel with urgently needed tanks and howitzers. These supplies were often deployed immediately upon unloading. With robust U.S. backing, Israel gradually gained the upper hand and secured victory. This aid operation perfectly demonstrated the C-5's critical role. Only such a large strategic transport aircraft could accomplish long-range, heavy-lift missions within tight timelines. During the Vietnam War, the C-5 and C-130 formed a seamless partnership. The C-5 transported personnel and supplies from the U.S. mainland to rear military bases, where cargo was then transferred to C-130S for final delivery to the front lines. This division of labor proved highly successful and exceptionally effective for large-scale transport missions. However, it became overly cumbersome in certain specialized transport scenarios. Consequently, in the late 1970s, the U.S. Department of Defense sought a new transport aircraft capable of fulfilling both requirements. Tactically, the aircraft needed to bypass major airports and fly directly to the front lines, eliminating the need for reloading and unloading cargo. This significantly reduced transit time. Consequently, the design team's primary task was to create an aircraft robust enough to reach forward operating bases and equipped with short takeoff and landing capabilities, as FOB runways typically measure only about 1 kilometer. Strategically, the aircraft must also meet heavy lift and long-range requirements to directly transport U.S. military tanks, helicopters, and other heavy equipment to the front lines. In 1981, Boeing, McDonnell Douglas, and Lockheed began competing for the new transport aircraft project. 8 months later, McDonnell Douglas secured the contract. The Department of Defense demanded the new aircraft be operational within 6 years. However, building this aircraft proved far more challenging than anticipated. Due to the stringent performance requirements set during the bidding process, many military officials believed this was a multi-billion-dollar waste on an impossible project. Initially, McDonnell Douglas planned to conduct test flights within 22 months. Yet, after a year, it became clear such a timeline was unattainable. New problems multiplied, driving costs skyward. The project soon exceeded its budget by $500 million, drawing congressional opposition. The C-17 is a $40 billion boondoggle, declared a congressional critic. Nothing more than a town car for the airport, added another. On September 15, 1991, in Long Beach, California, the C-17 prepared for its maiden flight. Senior Air Force officials attended to lend support to the troubled program. This maiden flight was critical for the C-17, directly determining the project's survival. The massive aircraft, weighing over 100 tons, began its takeoff roll down the runway. Successfully, the C-17 lifted off as planned, cruised over mountains, and landed. Yet this initial success didn't resolve all issues. A year later, the C-17's wings failed during static testing. The wing exhibited bending and multiple failures when subjected to 128% of its maximum design load, falling short of the requirement to operate at 150% maximum load. Combined with oil leaks near the engine mounts, this forced McDonnell Douglas to significantly increase investment and return the C-17 to the drawing board. July 1995, Charlton Air Force Base, McDonnell Douglas's final chance to redeem its aircraft. 8 C-17s underwent 30 days of rigorous testing here. Test pilots flew around the clock to push the C-17 to its limits, including airdrops, transporting various cargo, desert landings, tank unloading, and every conceivable extreme test. Ultimately, the U.S. Air Force found the C-17 met all requirements and exceeded many, leading to its successful entry into service. The C-17 Globemaster has a maximum takeoff weight of 285 tons, a maximum payload of approximately 77 tons, a service ceiling of 13,700 meters. It boasts a range of 11,600 kilometers when empty. Powered by 4 Pratt & Whitney F-17 turbofan engines, each delivering 18 tons of thrust, it achieves formidable takeoff power, capable of nearly vertical climb. Its maximum speed reaches 830 kilometers per h. Equipped with 12 full carbon brakes integrated with its massive wings, it redirects airflow to generate additional lift. Combined with uniquely designed engine reverse thrust, a fully loaded C-17 can stop within 500 meters. When reverse thrust engages, it even creates miniature tornadoes at the engine nozzles. For landings on sandy makeshift runways, the reverse thrust systems on all 4 engines redirect exhaust upward to prevent ingestion of debris that could damage the aircraft. Such demanding takeoffs and landings place equally high demands on the landing gear. The C-17 is equipped with a robust landing gear system. a single strut nose gear with 2 Dunlop tires, paired with a tandem rear landing gear featuring 2 double strut units, each supporting 3 wheels. This configuration totals 14 wheels, with each tire weighing nearly 170 kilograms. Such a rugged and capable aircraft inevitably demands extensive logistical maintenance. Before and after each takeoff, the C-17 undergoes a comprehensive brake system inspection. Each brake assembly features an easily accessible wear indicator. As wear progresses, this rod shortens until it aligns parallel with the metal plate, signaling the brakes require replacement. Every 180 days, the C-17 undergoes a 4-day full inspection to identify and rectify any potential aircraft defects. To facilitate cargo loading and unloading, the C-17's floor can be easily flipped to the side of the button-operated wheels. It uses K-type loaders to install new large palletized cargo, and can also transport various combat vehicles like Humvees, M1 tanks, M109 howitzers, and other artillery. For personnel, the cargo hold can accommodate up to 140 combat troops when filled with chairs in the center section. Beyond this, the C-17 can also function as an airborne hospital, featuring medical-grade oxygen, temperature control, call systems, and tiered stretcher racks, capabilities absent in other aircraft. The 4-tier stretcher racks can accommodate up to 12 stretchers, transporting 48 casualties. Overall, as a strategic tactical transport aircraft, the C-17 perfectly bridges the gap between the C-5 and C-130. These 3 aircraft form an iron triangle, covering virtually all transport scenarios. Each excels as the undisputed leader in its respective domain, rendering them irreplaceable. This dominance explains why other U.S. military transport aircraft have been phased out. However, it's worth noting that current U.S. military equipment development prioritizes multi-role versatility. If one aircraft can perform the tasks of 2, it significantly reduces costs. Production of the C-5 has already ceased, with plans to retire all C-5s by 2040. Undoubtedly, the C-5's duties will gradually be taken over by the C-17. However, the CJ-7 cannot encroach on the C-130's role. After all, no transport aircraft is more rugged, cost-effective, or durable than the C-130. Alright then, that wraps up this video. If you enjoyed it, don't forget to subscribe and give it a thumbs up. See you in the next video.